universal solvent. So if we list out all the activities we do, starting from the morning till going to bed, all our activities, 90% of the activities involves water. Without water, nothing can be done. When we come to a consumption part, irrigation takes the first place, followed by industries like us. Being located in Chennai, so all of us who are all here become responsible to conserve the water in each and everything we do. In early days, every house had a well. There was no restriction for usage of water. Everyone can take the water without any restriction. That was potable, sweet. We can use it without any hesitation or any fear. But totally, now it is a different situation. Nowadays, we can see the disputes between the states and the people fighting to share the resources among themselves. That too in a country like India. India teaches the world Vasudeva Kudumbakam. That is, the world is our family. Hence, each and every resources is common for all. We don't have any right to destroy or waste any resources which is abundantly available with us. Any good initiative starts from home. So, as a responsible citizen, we should teach our kids. We should be a role model. We should teach our kids how to save water, how to use it wisely, how to conserve it, what are all the implications if water is not available, and how to save it for our future generation. It is wholly our responsibility to take it to the next generation. If an individual can conserve some amount of water, please think if organization like us put together and work beyond our boundaries means, then the target of ICC is nothing. We can achieve it within the period of deadline itself. We can achieve, I think so. Talk about my organization. The products our organization chooses, everything is environmentally friendly. Nothing is harms the environment. We have 3 units. One is at Chennai, one is at Ranipet, and we are starting our 3rd unit at Naidupet, Andhra Pradesh. This is our industry at Chennai, and the second one is at Ranipet. Our products are ultramarine blue. It is an inorganic pigment. And the next one, it is done at both at Ambattur and Ranipet. And we are doing surfactant at our Ranipet division. It's a linear alkyl benzene sulfonic acid and alpha olefin sulfonate. It is a raw material for detergent. But still I want to share the quote by our Deiva Pulavar Thiruvalluvar. நீரின்றி அமையாது உலகெனின் யார் யாருக்கும் வானின்றி அமையாது ஒழிக்கு. தண்ணி இல்லைன்னா எதையுமே யோசிச்சு பார்க்கவே முடியாது நம்மளால. தண்ணி இல்லைன்னா தொழில் இல்லை, தொழில் இல்லைன்னா வாழ்க்கை இல்லை, வாழ்க்கை இல்லைன்னா உலகமே இல்லை. ஸோ வாட்டர் இஸ் த பேசிக் சோர்ஸ் விச் ஷுட் பி ப்ரிசர்வ்ட் அண்ட் விச் ஷுட் பி சேவ். இட் இஸ் அது வந்து ஒரு 2000 வருஷம். இட் இஸ் டோல்ட் பை ஹிம் பிஃபோர் 2000 years itself. ஸோ இன் அவர் ஆர்கனைசேஷன் we achieved this zero discharge plan through 4 R's. One is reduce. This is the prime motto for any action to reduce. First, we should eliminate from the source itself is the best thing to reduce the water consumption or the generation of processed water. Next one is reusing. We are reusing the water wherever possible. Recycle. We are processing the water and getting a pure water. That is water used for it is equivalent to fresh water. Next one is recovering. Recovering the water from wherever the sources possible. Reduce. For this reduce, we can do through many divisions. One is technology. In our organization, the water was mostly used in our washing process. We were doing our washing activity doing a conventional filtration process. For this, we may be requiring around 21 kL per batch. So then we thought of another technology which will have better water, that is filtration. So we went for pressure filtration. So we have recovered 30%, reduced 30% water. That is, we were able to do the washing with 14 kL of water itself. How this is happening is the conventional filtration system had only 80 square meter of area, so that the filtration was very slow and it was not that much better. In pressure filtration, we were having 17 square meter area, so that the filtration was better and we were able to reduce the water used for leaching the soluble salts. The second one is solid separation process. After different process, we used to separate the solid from the slurry. So for that, earlier we were using gravitational forced separation technique, which will give an output of product which will have 50% of moisture, that is water content. So it will, the 50% of water will be dried, or it will be dried through solar drying, or when we are drying the product, it will be evaporated. We won't be we won't be taking back the water from that process. Now, we are doing this activity of separation in a pressure filtration technique, which is the output, the solid which we are getting is with only 35% water content. So we have directly saved 50% of water per batch of a cycle. So with this technology difference, we were saving 15% water. Next one is, initially we were having a seawater membrane. Now we gone for another, that is high performance ROs, 2 numbers, so that we can bifurcate our water stream according to the TDS for the different processes, so that we were able to recover 98% of the water which we are giving for the RO system. The next one is, earlier we were drying our effluent in a mechanical evaporator. Same way as we are saying, the cake was dried in a dryer, or it was dried in a solar dryer, solar panels. So now we are using multiple effect evaporator, so that we can get the condensate of 90% water from this. So the water which was going by evaporation, now we are collecting is as a condensate. Next one is process modification. We try to reduce the water consumption by doing the process modification. We started working, the salt is coming in the formulation. So we are doing so many trials to reduce the salt content in the formulation itself. The trials are going on and we are achieving. Earlier we were getting around 1 lakh ppm TDS in a salt in a product, means now we are getting only 60,000. So with that we are reducing the salt generation in the source itself. The second one is, when we are washing, we introduce the air to make more agilent of the slurry, so that the solubility can improve. The next one is, when we are agitating the slurry in an agitator, we started rotating the shaft in both the direction, so that the leaching or solubility could be improved. And still we are doing further trials to reduce further on the extraction part. Next one is monitoring. We have to reduce, means first we have to measure. So we started incorporating flow meters in wherever area the waters are used, and identify the areas of concern, and asked the team to give for the Kaizens. So the team came with the Kaizen. The project was allotted to the team. They will be working on the water reduction projects. On seeing the results, it will be reviewed by our management. If it feels good, Then it will be parallelly deployed in other processes wherever possible. And this idea will be penetrated to the other units too. Next one is source elimination. As I told about solid separation, in that process, the particle size of the product will be very less, so it won't settle that much faster. We were using flocculant. This flocculant was diluted with the water, around 5 to 6 kL of water per batch. This batch was parallelly dosed along with the slurry in the G-force separation technique machine. Now, as we shifted to that pressure filtration technique, we eliminated the process of diluting the water and started adding that flocculant in the slurry itself and agitated and kept it for some time, so it got settled. So we eliminated the water which was used for diluting the flocculant for solid separation was totally eliminated because of this. Next one, reuse. We also done so many things to reuse the water to reduce the load to the RO plants. We have different stream of water with different TDS. So based on TDS, it will be diverted to different RO systems. The low TDS water will be used again for leaching the salt, or used in our scrubber system, or it will be used in our slurry filtration system. Like this, we are recycling the water wherever possible. So this was the stream of earlier and now. Earlier, we had RO plant. It gave 40% recovery and 60% reject. The reject water was evaporated along in the evaporator. The water got that evaporated and we recovered the salt. But now the same, this is example. I am taking 100 because it will be easy for calculation and remembering. So when we are taking 100 kL of water in RO plant, it is giving 40% recovery. So the 40% recovery is taken as a fresh water. That 60% water goes to the high performance RO, the next RO. So there we are further recovering 40% of water and 60% concentrate is routed to the next high performance RO, which is more efficient than the second one. There also we were able to recover 40% of water, and the remaining 60% concentrate is routed to MEE plant. There, earlier we are just evaporating the water and letting into, we are wasting the water, we are not recovering it. Now, we are collecting the 90% condensate and recovering the salt. So this is the just calculation part. So earlier, we were only recovering 40% and we were using the 60% of fresh water for our process. But because of the implementation of all these RO systems and different reuses inside the thing, we are now able to recover 98% of water from our process. This is for trade effluent. Now I am coming to domestic sewage water. That's earlier the sewage was routed to soak pits. Now we have commissioned our STP plant, so that this is used for the recovery is used for gardening purpose. For this gardening also, we have laid a clean line throughout the peripheral, so that when the water is recovered, when we are opening the valve with openings at different intervals, we will be having a wall. So when we open here itself, the water will automatically go to all the peripheral of the factory, so that the gardening is taken care by STP water without any extra effort. Next, recovery. We are having rainwater harvesting pits at various locations to enrich our groundwater level, so that there won't be any scarcity. Next one, in some of our roofs, wherever possible, we have laid a pipeline and routed it to a tanks. So whenever rain comes, so the water will be collected in tanks So with this, we can collect up to 40 kL of water. This can be used in a process. We are still working on rainwater harvesting, improving our rainwater harvesting and greenery with the effect of STP water. We are improving our greenery, and suggestion scheme give us a room to improve our areas where we can save more water and where we can reduce our processed water generation. So like this, we are working. This is not the end. We have done whatever possible by us. So we will work till we can achieve to the optimum level. So our organization, as I told, is a ISO 14001, 45001 and responsible care certified. So we commit ourselves as a responsible citizen to conserve natural resource wherever possible in each and every activity we do. So as I told, the resource is common for everyone. Let us join our hands to conserve them and save them for our future generation. Thank you.